In this video, I'm going to be walking you through a paired samples t-test. So for a paired samples t-test, we are comparing the means of two sets of non-independent scores. So basically what this means is that we're looking at a within subjects design. You might remember in the independent samples t-test, it's a between design group where the groups are independent of each other, so people can only be in one of the groups. For a paired samples t-test, we're comparing the means of a within subjects design. So basically we're comparing each person's scores to their own scores. So for example, if we did a pre-test, post-test, we're comparing how someone did on the first test versus how they did on the second test. So we're comparing the means of their scores to their own scores. So we're comparing that one person and not comparing two different groups of people's scores to each other. So this is always going to be a within subjects design, our paired samples t-test. We could also do this if we were doing collecting data in pairs. So like if we were collecting data from a married couple, they would count as one pair. So we would be comparing like one spouse versus the other spouse as one of the pairs. For this particular one, it'll be within subjects with us comparing how someone performed on one task to how they performed on a different task. So for this, we need our IV to be nominal data, so it has to be categorical. And our dependent variable must be at least interval. So we could have interval, ratio, or scale for our dependent variable. And so I'm going to show you how to do this, but before I do this, I have to talk a little bit about the data set that we're going to be using, because this one, we used it in class, but this is the only video that I'm making using this data set. So this is our Stroop task data set. So just to give a refresher, if you weren't in class, that kind of thing, on what the Stroop test is, it's basically for a Stroop test, we would show participants something like this here, where they're seeing a bunch of boxes of colors. And then what we would do is ask them to go down each item and name the color like as quickly and as accurately as they can. So like for this one, we would time them and say like blue, green, red, brown, purple, blue, red, green, purple, brown, green, blue, red, purple, brown, blue, purple, brown, red, green. And that is all we would have them do, and we would time how long that took them. We would see how many, we would note how many errors they made as well. And then the second part of it is they would see it like this, where we have lists, or we have different colors listed here, and we would have them say what color the word is instead of what the word says. So for this, and we would time how long it took them and how many errors they made again. So for this, it would be like blue, green, red, brown, purple, blue, red, green, purple, brown, green, etc. So we would go through that whole thing and see how they scored on this. And this, the idea that we perform, our performance is worse on this category is because when we're trying to say just the color, our brain is trying to make an inference as to like what the word is and infer the meaning of that word. So when we're seeing this blue text, our brain is reading the word red, and it's hard for us to say blue because we're reading the word red and our brain is thinking red and inferring that from that. So that's the Stroop phenomenon, is that it's like difficult to just say, like to ignore the context and just say the color. So the idea for this data set that we're going to be looking at for the paired samples t-test is that participants will it will take them longer to do this version of the test, which is called, I believe, the words condition, than it would take them to do the squares condition, which the squares condition was just those squares with colors inside of them. So we're comparing how long it took them to do both the squares and the words task, and then we're also going to compare how much error they had on both the words and the squares task. Hopefully that makes sense. So what we're going to do for a paired samples t-test is in analyses, we're going to click on t-tests, and then we're going to select paired samples t-test, And now this one will look slightly different than the other ones we've seen so far. So we're gonna leave everything on this side as it is. I believe that we will check off some things after we add in everything, but what we're going to do is we're going to create pairs. So our first pair that we're going to look at is how long it took them to complete each condition. So we're comparing individual participants to their own, like comparing how someone performed on the words task and how they performed on the squares task. So the first thing I'll do is I'll move over this time squares. I'm going to do squares first because that should be the easier one, the first one that I showed you, and just putting it in the order that they should have actually seen it might make it make a little bit more sense. And then I'm going to put the words one and I'm going to drag that over to the right side so that it fits in there. So that's how we can see that this is a pair. Now we could do this, I'm going to show you first with just this one so that it's simpler. More simple, wow. So we're going to check off the effect size and we're going to check off the descriptives. I think we can, yeah, we can check off descriptive plots as well. So here, much like the independent samples t-test, our first table here is the actual t-test. So it's looking at the pair of how long it took them on the squares and how long it took them on the words. So then it just shows our t, that we're getting a t statistic, and then the statistic here is the t statistic because it's a t-test. So it's negative 8.51, and then we would report 60 degrees of freedom. We don't need to put this 0.0 in there. You can just put 60 degrees of freedom. And we can see that our p is less than 0.001. So that it appears that there is a difference in participants' scores on the squares task versus their scores on the words task. Versus their time on the words task. And then we would look at our effect size, which is negative 1.09, which is a large effect size. And we know that because it's above a 0.8, and that's kind of like an absolute value. So like it's even though it's a negative number, it's still like above 0.8 in an absolute value. So we would say that that's a large effect size. And then looking at the descriptives here, we can look at the average to see which group is scoring which way. So we can see that for the squares group, which was where they just saw the color, the average time it took them was about 9.5 seconds to complete it. And the words group, which was the one where they had to say the color and not the word, it took them an average of 22 seconds about to complete it. So it took that group significantly longer to complete it than it took the squares, or than it took participants when they were doing the squares test. So we can see participants in our plot here, it took them a lot less time to do that one than it took them to do the words task, and we can see that these confidence intervals are not even close to overlapping, so these scores are definitely very different from each other. And I want to just show you one thing with the with that effect size being negative. If we were to put it, I think that this should work. If we were to put this where we had the words group first and then the squares group, our effect size would be positive, and it's just because the difference from this to this was like when we had it in the other order, it showed it as a negative number. So really that's why we're just looking at the absolute value and not necessarily whether it's negative or positive. We're just looking at whether it's above a certain threshold, and that threshold for a large effect size for a Cohen's d is above a 0.8. So either way, whether it was a negative 1.09 or a positive 1.09, it's still above that threshold. Hopefully that makes sense. Okay, so now I'm going to add in looking at error as well. So I'm going to keep it in this order just since we're already in this order. So if we're looking at how much error they made in each condition, so that added another line here. So we can just kind of compare do multiple t-tests at the same time. So now looking at error, we have our student's t again. It's a 4.05, 60 degrees of freedom again, and our p-value is once again less than 0.005. And here we have a Cohen's d of 0.519, which would be a medium effect, because I think we talked about how it's between 0.5 and 0.8 would be a medium effect. So we do see a medium effect there. And like with the other one, if we had put these in the opposite order, it would have shown a negative value here, but either way just means the same thing. So now looking at the error ones here for the mean, we can see that there was significantly more error in the words group than in the squares group, which makes sense because we know that this is supposed to be the harder task. So it makes sense that they made more errors. And now looking at the plot for that one, we can see that the words group, who had to read the say the color and instead of reading the word, had a higher error. So we can see that in our figure here. The confidence intervals are pretty large, meaning that there was some variability in how many errors people made. And then we have the average for the squares group. And the reason that the confidence intervals are almost non-existent here, like you can see that they're right on the score, right on the average here, is likely that there were very few people who made any errors at all in that on that task. So it's likely that there was like maybe one person who made an error, and they were the only person. So there's not really a difference here. So there wasn't like a range of scores. So if there was a range of scores, we would see those confidence intervals. But because everyone pretty much scored exactly the same on that, we don't really have any confidence intervals there because everyone was the same. Hopefully that makes sense. And that is all you do for a paired samples t-test. All right. Thank you for watching this video, and I will see you next time.